Okay, so this is the given problem. Given the condition x is equal to a nor not b and not a and b. Okay, use the appropriate logic circuit symbols, draw the symbol, blah, blah, blah. Okay, so I have a and b there. We're going to draw the circuit there. Okay, from a to that is supposed to be a NOR gate, and then going to another circuit there, and that is supposed to go to which gate? That is supposed to go through the NOT gate. Okay, let's just undo this. So let me delete that. Just try to draw it as short as possible. Okay, and then we have a NOT gate. There we go. Okay, now the NOT gate, they are meeting at a NOR gate. So we're going to find a NOR gate. Mr. NOR, there we go. Put your NOR gate there. Can we move it right there? Okay, let's try to see if this will work. Yep, definitely will work. Okay, let me just draw that there. And voila. So that's done. I can label this result as as D, as C, sorry. No. I'm gonna call this B. Okay. And then I'm gonna call this C. Okay. Why am I doing this? I like to call all my results. I like to give all my results labels. So whatever result I get from there, it's gonna be labeled C, D, and so on. Okay, now the next one, these are all going through an AND gate. But first, let me get the not A. Not A. Where do I get the not A? So let's say not A, and then they go through an AND gate with B. Yes, let's rather do this. So that goes there, and just a bit, and that goes through a NOT gate. Let's move that, right. And then we're having a B right there. And these two will go through, what do we call it? An AND gate. So let's have an AND gate right there. Let's move it. We can have that right there. And then, okay, we can't do that. So we have to connect it. Let's say, yeah, that can even work. Okay, so we're gonna have, this label is gonna be E. C, D, E. Okay, so we're gonna have an E there, right there. So once it goes through an A gate and not A, that's a not A, that's gonna be, the result is E. Okay, and then B and not A, or let me say E, they're going through an AND gate, so they're gonna give us maybe F. Okay. Remember, you can use any letter. If you don't want to use the letters, it's also fine. Okay, and then all of them go through an AND gate. Okay, so we're gonna have our AND gate right there. Let's move it, yeah, just there. Perfect. Okay, then the final connection, that will go there, that will go right there, and this will give us our final result, which is X. Okay, I think that's perfect. Okay, let's see now if I just want to get rid of the selection of X. Let's put a full stop somewhere. Okay, good. So now there's our logic circuit that is done. Next one now. Now we need the truth table. Okay, so I just want you to remember that the NOR gate is basically the opposite of the OR gate. Usually the OR gate is addition, so if it's 0 plus 0, that gives us 0 normally, but if it's the opposite, then it is 0 plus 0 is 1, 1 plus 0 is 0, 0 plus 1 is 0, 1 plus 1 is 0. That is the opposite of the OR gate. Okay, moving on. Now let's go into this tutorial. Okay, so remember I said not B is C, so that will be C there. I wrote it there just in case. Now, let me just see if I can center all this. Let me just center right. So, not B is the opposite of B. So this will be, let's see, maybe I can just expand this. No, I don't need to expand it. Let me just do this. Yeah, that's better. Much bigger. Right. So not B is 1 there. 0 is the opposite of B, right? Okay. And then A nor C, so that means this result here is a C. Okay, so this C is going through a gate with A. Okay, so these ones are the NOR gate. So 0 plus 1 is normally 1, but because it's a NOR gate, it's opposite. 0 plus 0 is normally 0, so the opposite is 1. 1 plus 1 is normally 1, but the opposite is 0. 1 plus 0 is normally 1, so the opposite is 0. Okay, so now we have D. This is the D that we spoke about right there. Okay, so now we are going for not A. So not A, we are trying to find that E right there. Okay, so now not A is basically the opposite of that. So that will be 1, 1, and then 0, 0. Okay, so not A is done, but we now said not A is now equal to E. So we have E and we have D as a result. Okay, so we have E and D. Okay, don't forget that. Now, before we can use D, we are going to first find F. And in order to find F, we are going to take E and go through the AND gate with B. Okay, so we are looking at B and we are looking at E. They are going through an AND gate. And AND gate is basically multiplication. So 0 times 1 is normally 0. 1 times 1 is normally 1. 0 times 0 is normally, sorry, this is 1 actually. And 0 times 0, so we're looking at this 0 multiplied by that 0 will give us 0. And then 1 multiplied by 0 is normally 0. Okay, so the AND gate only gives us an output of 1 whenever both inputs are 1. Okay, so this is the only scenario where where the result is 1. So now we have F. Okay, so B is done. Okay, so let's say, sorry. So E and B, we now have F and we have D. Now D and F are going through an AND gate. So they are close to each other in this method. So this is what gets us X. That's why I wrote X is equal to D and F. Okay, so 1 times 1 times 0 is 0. 1 times 1 is 1. 0 times 0 is 0. 0 times 0 is 0. And this should be the answer. Okay, I didn't look at the memo, but this should be the correct answer. Okay, please don't hesitate to contact me if you need more.